first of all, I had to figure out the source of the hydrogen, which I'd kind of learned to do from my vehicles. But then I had to convert a stove. The stove has these burners, and you turn on the gas and it ignites and you have a flame. Well, I got a stove and I converted the burners so they would use hydrogen. I turned on the flame. I could hear it making a noise, but there was no fire. There was a little pilot light, but there was no fire. There was no flame. I put my hand over it and it was hot. The hydrogen flame is invisible. It's not blue, it's not yellow, it's invisible. You can't see it. And I thought, oh, that might be dangerous. If people turn on a hydrogen burner and there's no flame, and you think, whoa, it's not on, they could roast their fingers, which wouldn't be good. That's a problem. Another thing I did is I took a sample of the gas above the burner just to make sure that it wasn't making any pollution. You know, when you burn hydrogen, it only makes water vapor. No pollution, no carbon dioxide, no carbon monoxide, no unburnt hydrocarbons, just water. Except in my hydrogen car, I found out it also made nitric oxide from heating up nitrogen and oxygen in air and turn them into this pollutant that's kind of bad. So I wanted to make sure there was none of that. So I pulled a sample, took it to the chemistry lab, and there was 1,000 parts per million of nitric oxide. That's terrible. That is dangerous. And so I thought, oh, gee, you can't have this in a house because there's too much nitric oxide. I needed a solution. You know, the optimism curve, I started out very positive. I built the burner, I tested, and then it was very discouraging. If you look in the United States Patent Office, you're going to find a guy named me,
Roger Billings,
with an invention to make a kitchen stove work without any pollution.
I didn't know that.
Oh, yeah. And you legal people will realize, and it's expired. It's been a while back. It only lasts 17 years. This was before that. But I had to get rid of that nitric oxide. And I had to figure, if we're going to put these in everybody's homes, it's got to be affordable. It's got to be reliable. And it would be nice if it made it so you could see if there was a flame, too. And so I started the inventive process. I had to discover how to make this work. And I have this little laboratory that I build in my brain, which means I've tried a lot of experiments. I like doing them in my brain. When my homemade theoretical imagination laboratory says it'll work, then I try it. And if it doesn't work, I have to go fix my laboratory. So, and eventually you get so that you can do more and more experience in your head and be more and more accurate. Well, I did a lot of experiments, and eventually I came up with a really interesting idea. And it's interesting how almost all the bad news in science sooner or later can be used to your advantage. My early hydrogen engines would backfire. Boom, boom, boom. That's why I had such a hard time getting the first lawnmower engine to run, because it would backfire. Well, I discovered the reason it was backfiring is when the engine is drawing in the fuel during the intake stroke, that there was metal inside the engine that was warm from the last cycle. And when you have iron, just plain old iron or steel that is hot, it's a catalyst that ignites hydrogen. So while the intake's still coming in and the valve is open, it'd catch on fire to burn out through the intake manifold, and boom, and it would scare everybody away. So I had to work very hard to solve that problem in my engine. And so now I have a problem here. I can't see the flame. There's pollution. Pollution is caused when you heat nitrogen, which is 80% of air, and oxygen, which is almost 20% of air. When you heat those two gases, when you heat air up to a temperature above 2,400 degrees, they react and form this nitric oxide. In my engine, I got rid of nitric oxide by lowering the combustion temperature. And I did that by spraying little droplets of water in the cylinder. Can't do that on a stove. So I got this idea. If the hot iron ignites hydrogen like a catalyst, I went to the grocery store and I found a stainless steel scrubber. Have you seen those? They're there. There's just stainless steel scrubbers, and they're only like 50 cents. So I got a couple. I brought them home, and I stretched them over the top of the burner. My theory was when the stainless steel got warm, it would be like a catalyst to make the hydrogen burn when there wasn't a good mixture of air and oxygen with the hydrogen, so it would be cooler. And as it got hot, it would glow orange. So lo and behold, I turned the thing on, the fire ignited, and the stainless steel catalyst turned a bright, beautiful orange. And we measured the pollution, and instead of 1,000 parts per million, there was less than 1 part per million.
You're so smart.
And so I have a patent. Now, I like to think about that as kind of the model for discovery learning.